Namaste people. So in this video, we're going to have a look at NumPy, which is a very important library for the purposes of data science and data analytics in Python. And the reason it's very important is because we usually use it in place of lists. And the reason we do that is because it is more memory efficient. It usually expands to n-dimensional objects very easily. The speed of calculation is faster. Broadcasting operation and other functions are already available for NumPy, and we don't really have to code that. We usually have to do that with this. And thus, for all these reasons, it's very popular with data science and analytics people. All right, so let's get started with it. So let's import NumPy first. Import NumPy. I will import it as np, so we don't have to use NumPy every time. We'll just use np as alias, right? So if you have not installed Python in your computer, first you will need to install Python. Either you can do that directly from the Python website, or you can do it through Anaconda. If you've done that through Anaconda, you can import similarly install NumPy using conda install, or if you have done Python through its website, you can just install NumPy using pip install. All right. So let's create a list first. Let's call it my list, and it will have elements 1, 2, and 3. To convert this to a NumPy array, all we have to do is write np.array and then pass the list in it. As you can see, it will now be converted to an array of NumPy 1, 2, 3. We can do the same thing with any matrix, and in Python, as you know, the matrices are usually denoted in the form of nested lists. So let's create a matrix called my matrix equal to, let's just have the first row as 1, 2, 3, the second row as 4, 5, 6, the third row as 7, 7, 8, 9. All right. So we have this. Now to convert this to a NumPy array, we will just have to do the same thing as we did above. np.array my matrix. As you can see, now it has been converted to a NumPy array. After this, there is a lot of functions that we can use on NumPy, and we'll look at that next. But before that, if you want to save this in a variable, you can do that. For example, you can use arr equal to np.array, so this will get stored in this, right? For now, we don't need to do that for this, and we'll move forward to the built-in methods. So the first built-in method is arrange. What arrange is, I will show you. So first of all, let me tell you the syntax. So you will have to write np and then call using dot operator, of course. So np.arrange. Let's have a low and a high range. By default, let's have it as 0 and 10. And when you execute this, you will see that you will have an array, a NumPy array from 0 to 10, not including 10, non-inclusive. All right. So this will go from 0 to 10, and 10 is not inclusive. All right. So as you can see, the default step size is also 1. You can actually change the step size as well for NumPy arrange. So I'll show you how to do that. np.arrange 0, 10, and then the third argument could be your step size. So here the step size would be 2. As you can see now, 0, 2, 4, 6, 8, and then 10 should be there, but in this function it is not inclusive, so it will not show up. So you will have an array of 5 elements from 0 to 8 with a gap of 2. All right. So this is arrange, and the next one would be zeros. So if you want to generate a vector or a NumPy array of zeros, so you'll just have to write np.zeros. And in this argument, you can have how many elements do you want. So let's say you want 5 zeros. So you'll have an array with 5 zeros. Similarly, you can also have a 2D array of as many zeros as you want. So if you want a 2D array, you will have just np.zeros, and then in parentheses you'll write a tuple of, let's say, 5, 5, 5. So you'll have 25 zeros arranged in rows of 5 each. All right. Similarly, we have another function which is called ones, which does the same thing as zeros. Instead, it does it for 1, right? So np dot ones is the name, and it has the same function, so but it does it for 1, right? Similarly, np dot ones, let's give a tuple of 6 comma 6 this time. As you can see, 6 rows 6 columns, 36 total ones. All right, and the next one would be linspace. So linspace is very nice. It is a bit different from arrange, and I'll show you how. So let's have linspace from linspace, linspace. This is the function name. Let's say 0 to 10. All right, so as you can see, this will create equally divided from 0 to 10, 10 inclusive, so the end is inclusive. It will create equally divided array. So if you want to control how many of these will be divided into, so let's say we want 100 divisions between them, we can have that. If you want just 5 divisions in between them, we can have that. So as you can see, it is a bit different from arrange. In arrange, you will have array from the starting to end not inclusive, and you can change the step size. All right, here you will have a start and an end inclusive, and you can tell how many elements do you want between them equally spaced. All right, so this was linspace. Let's go to the random functions now. Okay, so let's say you want to generate a vector or an array, NumPy array of random values. All right, so how do we do that? So we use np.random, and then if you want the values to be 0 and 1, we usually use rand. And let's say you want two values, so using rand you will actually get values between 0 inclusive and 1 exclusive. So this is excluded. All right, so let's say you want 5 values now, so we can use the same function and just put 5 in the argument. So we will have 5 values, and as you can see, again all of these are between 0 and 1. Now what if you want something from a normal distribution? So that is very easy and very similar as well. So you will just have to change from rand to rand n. So this will give you the values using from a normal distribution, standard normal distribution. All right, and if you want more values, that is also possible, of course. So let's say you want 10 values, you will have 10 values, right? So let's say you don't want a vector, you want a matrix and matrix array. So we can do that as well, of course. So in it we can just pass 2 parameters instead of 1. So let's say we want 5 comma 5. So we will have a 2D array, and all of these values are from a randomly selected from a normal standard distribution. All right, and if you want integers and not from a normal distribution, that is again very easy. So you can have it as, instead of randint, you will have rand int, and the arguments are a bit different. All right, so first you will have a minimum value from the integer in which you want to select from. So let's say I want to select 0. From 0 to 100, it will select values. All right, so if you have only 2 arguments, it will select 1 value, and that won't be in an array. If you want more than 1 value, so let's say we want 5 values, the third argument will be the number of values you want. Now this time if you have more than 1 value, it will come in a NumPy array, of course. All right, so this was it about random. So let's see how we can reshape a vector or an NumPy array. All right, so let's first create an array. So arr equal to np dot, let's create it from random numbers, randint. So let's have from 0 to 100, and we want 20 values or maybe 25 values. All right, so we can check what is there in it. So as you can see, we have 25 random integer values. So what do we want to reshape this array into a 2D array? So we have a very useful function called reshape. So so we can use arr.reshape, and then we can just pass in the parameters as to what reshape you want first. So let's say we want 5 comma 5, and you have to make sure the multiplication of this will be the number of values, and that has to be the same as the number of values in the array which exists right now, of course. So if let's say I do it as 4 comma 4, that would be 16 values, and in an array there are more than 16 values, it will throw an error for you. All right, so you have to make sure the multiplication of these two are the same as the number of elements in your array right now. So if you reshape it, as you can see, now it has been reshaped into 5 comma 5 2D matrix, right? So, and there are few more very important useful functions which can give you a maximum minimum from a particular NumPy array. So we will check that out as well. So let's say you have an array which is, let's take this array itself. So you can use a function arr.max. So this will give you the maximum value from this array. Similarly, there is a minimum function arr.min, right? Now there is argmax and argmin. Uh, argmax, see, and then you have argmin as well, which will give you the argument of the minimum integer. All right, so I hope that is clear with you. We'll meet in the next lecture.